Welcome back to C# Tutorials for Beginners. This time we're doing abstraction. So before we get started with abstraction, you need to be familiar with inheritance. So if you haven't watched number 24 and 25, I recommend that you do so. Next, before we get going, you need to have a relatively clean main, a person class with a first and last name and a getFullName method, an employee class that inherits from person, and a doctor class that inherits from employee. So a subset of what we did in the inheritance videos. So let's hop back over to person and let's talk about abstraction. Abstraction is a core object-oriented programming concept. We use abstraction to hide away certain logic so that we expose only what we need at any given level. And that may sound confusing, but think about it like this. So right now we have a person. Employee inherits from person, which means person gives employee the ability to have a first and a last name. Well, a first and a last name are not that complicated. So if we gave an employee a first and a last name and a doctor a first and a last name, that wouldn't really make things more complex. Now it would be duplicating code and that wouldn't be good. But it doesn't really show us why we need to abstract something. So suppose in person, we had something extremely complicated, maybe like working with DNA. Like say we're sequencing this person's DNA in some insanely complex way in this class. Well, by the time we got down to doctor, we don't want to know anything about this person's DNA. We're concerned with the doctor's specialty and maybe what surgeries they're performing. We don't want to see any of that complex logic at this level because that makes it harder to find out what's wrong with a doctor specifically, or maybe something's going wrong with an employee specifically. And we don't want to see that person logic, so we abstract it away so we can only see what we need to see. And that is why we want to use abstraction. Now, in hiding away these details, that means you can't create an object of an abstract class. So if we add the keyword abstract here, making person an abstract class, and we go back to program, and we try to create a new person, it's going to tell us you cannot create an instance of the abstract type or interface person. So now that we've made person abstract, the only way to access these details is through inheritance. So we can't create an object person, but what we can create is employee, and employee is a person. So we can come in here and create a new employee, but it's important to note that abstraction does not prevent us from using the type as a container or an argument, so we can still implement polymorphism. So an employee could be assigned to a person variable, a method could take a person type argument, you could still have a list of person. So polymorphism is still a thing, you just can't create a new person. The next thing I want to point out is that you can have publicly accessible methods with code inside of an abstract class, so that your employee can still call getFullName. You can still use all of the public logic inside of an abstract class. That being said, since we are an abstract class, we now have the ability to create an abstract method. So I can say public abstract string getDescription, end it with a semicolon, and now I've created basically what is a blueprint for anybody who inherits from person. To understand abstract classes is to understand this concept right here. So this is very important. The first thing that this does is it forces any implementation of person to create a getDescription method. So if we go look at the employee class, you'll see we have an error now. Employee does not implement inherited abstract member person.getDescription. Now you can go to this light bulb and select implement abstract class, or you can hold Control and press period and do the same thing from here. And what that's going to do is it is going to automatically insert the code that has to be overridden, which in our person class is getDescription. Now, if we added another abstract method, it would also be implemented alongside getDescription here. So let's take a look at this method. Visual Studio automatically adds a line of code that will throw a new error if you forget to implement the body of your method. So let's go ahead and implement that, and we'll discuss this more when we do error handling. So let's say our description is going to be the full name plus a comma plus the employee number, and that's good enough for now. So next let's take a look at the override keyword. So you have to use this keyword when you are overriding an abstract method inside of an abstract class. So you're letting C# know that this getDescription method is being implemented in employee right here. So that brings us to our next very important point. So the first one being that we were forced to implement this method from our abstract class, so our blueprint has to be enforced since we inherit from person. And that's great. But the second thing is that what it affords us is that now that we have this blueprint and it has to be implemented everywhere that it is inherited from, that means we can use it generically from the person type. So if person is an employee, we could say person.getDescription, and that is not going to run this abstract method because there's no code to run. But what it will do is it will say, okay, this person is actually an employee, and it will call the overridden getDescription method of the employee. So let's see this in action. Let's set our employee's details, first and last name, and our employee number. And now we don't need get full name. So now our person is our employee and we can call getDescription. So let's print that to our console. And now when we run it, we get our description method from our employee, even though we're calling it from a person type. So now let's take this one step further so you can really see the value of abstraction. So the person has an abstract getDescription method that we have overridden in employee, and we can call it generically. But doctor inherits from employee as well. So what if we wanted a getDescription in doctor? So first let's go back to program and create us a doctor. A doctor equals new doctor. Let's give the doctor a first name. We'll call him Doc. Let's give doctor a last name. We'll call him Holiday. And let's give doctor an employee number, which will be 1. And then let's give him a specialty, which will be brain stuff. Okay, that should be an int. Now let's create a new person to assign doctor to. It can be person 2, and he can be equal to our doctor. And now let's grab this line here, and let's write our doctor's description right after our employee's description. So that works as we would expect because we're calling doctor's getDescription method, which doesn't exist because we're inheriting employee, we get this description method. So this may be exactly what you want. You may want everybody that's an employee, be it a doctor, a nurse, custodian, whoever, to have the same getDescription method that is their full name and their employee number. And that would be fine. But maybe you say, well, doctor has a little bit more specific of a description, so you want to override the employee's override of the abstract method. So employee implements the abstract method, but maybe doctor is going to override it again. So we could take the method, we could go in here and we could put this here, and maybe we wanted to add, say, the doctor's specialty, and we could do that. If we go back to program, we're going to write this doctor's description already. So if we run it, now you're going to see that this person.getDescription is calling the employee override, and this person is calling the doctor override. So now hopefully you can see the usefulness of abstraction. You can declare a class that can't be made into an object, but all of these things can be used to force a blueprint on the rest of your code that both hide the details that you don't need to see and enforce that certain details are implemented in inherited classes. Please keep this code around because next time we will be working off of it to learn the base keyword and make our inheritance a little bit easier to write. So thank you for watching, everybody. I do appreciate you. Happy coding, and until next time, as always, take care.